In this video, we're going to introduce you to RidleyIQ. This is the latest feature that we've added to RidleyWorks. It's a culmination of over 30 years development, working with automated software development for power converters, and finding solutions to the problems much faster than you ever could before. So let's get going. Let's start a design here.
Click on specifications to start your design.
So here we have a power converter with an input voltage of 350 to 400 volts, 12 volts output, 10 amps, and 200 kilohertz. Let's go change the specifications so that you can see this is not a canned converter. So let's go in here, let's change that output voltage, let's say 19 volts on there, and let's do 12 amps. So we're upping the power level a significant amount.
Setting power level.
Just click
Design
OK there.
complete.
The design is
Simulating.
complete, so we've gone through a complete design of the converter, all components. Now we look at the current through the inductor, and here it is during startup. Notice we have a full built-in simulator with RidleyWorks. It's simulating a lot of cycles, and we want to look at this inductor current. We want to see it here coming during the current limit during startup, and we see we've got about 16 amps of peak current there. And then we continue. There's a steady state current. Let's zoom in on that a little bit. And now we can see we've got 4.5 amps or so of ripple current, and we've got 12 amps on the output. So there's our inductor value, about 13 microhenries, running around 12 amps DC. Now we want to go in and design not just the value of the inductor, that's the first step, of course, for determining the ripple current that we're going to see everywhere, and there's a lot of factors involved in making that choice. We won't cover those here. But let's go look at the actual design of the inductor itself. And we click on the inductor icon. And when you first arrive on this page, you'll see the schematic of the inductor. It's got DC resistance, AC resistance, a core material, and so on. Here's the inductance that we're looking for. Here's the current that we're looking for. Now, this is our manual way of designing that everybody's used in the past in our courses. And we kind of like using that in the course because it forces you to be involved in the process. Some of us are too busy and you just want a fast design. And that's when you turn on RidleyIQ. This is the most advanced design process that you can find in our industry. And it's all included with RidleyWorks. It's not an add-on. It's just a standard part of the package. So here under core types, you can see we have several choices. You can choose a generic core where you say, okay, I'm not ready to choose a particular core yet. Or you can choose a very specific core. Maybe your company already has a core that you think is about the right size and you can force that value. Or you can say, let's work in a family. So here we're choosing the RM family for design. Nothing special about that. Let's change it to the PQ family just to do something different. Okay, here's our PQ family. And we're going to use a magnet wire design for the first attempt. And to do the design, all you do is click on RidleyIQ.
Simulating to steady state. Core selected. Optimizing winding layers. Optimization complete. Inductor has been designed with RidleyIQ. Total inductor loss 1.575 watts.
As you heard there, the RidleyWorks talks to you, RidleyIQ talks to you, tells you what it's doing. It goes and selects what it thinks is a suitable core for the design, and then it goes and lays out the windings to give you a summary of all the losses. If you want to see that summary, you click on the summary button up here. And here's our present design of about 1.5 watts of loss. And then if you want to save that design, you want to try something else, you say, okay, well, let's save that design into number 1 here. And then there's a plot of our inductor loss at that point. You say, okay, well, I've got, 1.5, 1.6 watts of loss in here. Maybe that's too high for you. And you say, well, I'd like to try something else. You could try a bigger core if you want to, But let's try using a different winding type. Let's use a planar foil
Helical foil.
right here. And when we do that, there's actually no optimization to be done. It's still going to use the same core size, and there's no changing the number of layers of winding. There's only one choice for this planar foil. So we're actually complete with the design. So here's our second design point, where we've got down to 0.9 watts. So let's save that as design number 2. And you can do as many designs as you like. Suppose you say, okay, well, let's try a bigger core. I want to make it bigger to get lower losses. So you can nudge up the size of the core here.
Increase core size.
And then you say, let's go through RidleyIQ again.
Simulating to steady state. Selected.
Now it's chosen a bigger core,
Inductor
the
has been designed with
2614.
RidleyIQ.
That's the next one
Total
available
inductor loss
in
is
that family. And there we've got our third design. So we click on the third design here. Save that one. So now you can see how we reduce the losses by going through different options. You know, a lot of time I see people very confused about inductor design. And the main confusion really comes from there are an infinite number of solutions to the problem. It really doesn't have to be that difficult. And if you build in RidleyIQ and RidleyWorks into your design process, you're going to find that designing the magnetics, making the magnetics is a pleasure. It's just part of the process. It's quite easy to do. And a lot of power supply manufacturers and other custom converter manufacturers are discovering these days that, hey, making the magnetics yourself is probably a good idea a lot of the time because you have full control over the magnetics. Anyway, integrate RidleyIQ into your design process, and you're going to enjoy doing this so much more. Thank you.